Hi folks, so this is question 9, so we're back to trigonometry again. Um, we're asked to work out BC here, the length from B to C, so an airplane is travelling there. One thing you can fit in at the start anyway, the distance from A to B, he goes 2 hours at a speed of 420, so the distance then, so remember it's DST, so distance is speed multiplied by time, so distance there would be the 2. The speed first anyway. So speed is 420 and the time is 2 hours, so that would be 840, so 840 kilometers there. Now you don't really need to know that to fit that in to do this. You could use the cosine rule then and just go on and use this angle in the middle here, and your B and your C would be the 840 and the 1450. Another way, I think an easier way of doing it, is to use the sine rule. So you'll see there you've got a straight line, so all of that would be 180, so take away 20 from it and it's 160, so 160 is the angle in there. And I always find using the sine rule is just that little bit easier than using the cosine rule, not much in it. But if we pick opposite sides, so 1450 over sine of 160, that has to be equal to, and we'll call this the BC, so we'll call that X there, that's what we're trying to find out, over sine of the angle opposite, so sine of 8.57. So you can just rearrange that then, so you can just move over the sine of 8.57, so 1450 over sine 160 multiplied by sine of 8.57, and that will give us X, and you can just use calculator then. So that is 631.901, and we're rounding off there. So that is the distance then from B to C. It's asking us though for the time. So remember, then time is the distance over the speed, so T equals D over S. So the distance we know is 631.901. And the speed then, that's just going to be the same again. It's always going to be 420. The speed doesn't change. So if you put that in your calculator then, so you should get 1.506. Sorry, 1.504. Five and so on. So yeah, they want us to give the answer to the nearest minute then. So what we've done here is we've worked it out pretty much in hours, because it was kilometers per hour and so on that we've been dealing in so far. So think about 1.504 hours, so 1.5 hours would be just 60 plus another 30 minutes, so that's going to be 90 minutes. So 90 minutes is your final answer. That's to the nearest minute, and that's rounded off. So there's a good bit of work in that for the first part. Right. So the second part then, so it's about fuel consumption. So they're asking us, can it fly all the way around? So can it go from A to B to C and back to A without refueling? So you can fit in some of the things that you know already. So this was the distance here. That's kilometers. We have the distance from A to B. We also have the time now from from B to C. That's 90 minutes. And we know from the very first sentence in part A that it took 2 hours, so it's 120 minutes. So 120 minutes from A to B. Then, so we have the distance and we have the time for AB and BC, but we don't have the time for CA. So we can work that out. So the time was the distance over the speed. So distance is 1450 and the speed again is 420. It's always 420. So if you put that in your calculator, you'll get 3.45, and that will be in hours. So we have the other things in minutes, so I'm just going to times that by 60 and it'll just change into minutes. So we're going to get 207.14 0.14 minutes. So 207.14 minutes. So we have the time that it takes to go all the way around. So the time that it takes all the way around is 120 plus 90 plus the 207. So if we add up all them together then, we get 417.14, and that's still rounded off, and that is in minutes. Just look back at the question here then. It gives us what the average fuel consumption is, so it's litres per second. So we know for every second that it's in the air, it's going to take 3.8 litres of fuel, which is a lot when you think about it. So we need to just convert this into seconds. So if I times it by 60 again, it'll convert it into seconds. So it's 25028.57 seconds. So the plane is basically in the air for that amount of seconds. So that's how long the plane is going to be in the air for altogether, and it's going to use 3.8 litres for every one of those seconds. So therefore, to get how many litres the plane will use altogether, we're going to times it by 3.8, and this will give us then fuel used, or fuel required for the trip. So if you multiply those two together, you get 95609. Point, and it's one, yeah, probably kind of 0.2. So you'll see, anyway, that is less than the 100,000 litres that the plane has. So that because you can put 100,000 litres in the plane before you go, and it only uses up 95,609. So you've got 5,000 litres there left over. So it does, so it does work out. You can get all the way around with that much fuel. So you've shown it. Right, so for part B, so we have, it just gives us this function here. So 110 root 2 sine 120 pi t. Okay, so they ask us for the period first. So the period will just be the full circle, the 2 pi divided by the part that's in here of the function. So it's going to be 120 pi. And you can just use calculator then. So 2 divided by 120 gives you 1 over 60 of a second. So that's the period. The range then will be given by the part outside of the brackets, basically, or outside of the sin. So it's going to be the 110 root 2. So 110 root 2, and it's plus or minus that. So plus or minus 110 root 2. Right, so for the second part you have to sketch the function. So just putting in my axis here like this. Now we have to indicate the period and the range. So the period, the 1 over 60, we'll put it here, and then if you think about them, we can put in some other values. So 1 over 120 has to be what halfway would be. So 1 over 120 is halfway between 0 and 1 over 60. And then another 3/4 of the way would be 1 over 80. And then 1/4 of the way would be 1 over, and we double 120, so it would be 240. And then our range has to be what's up the side, so it'll be the 10 root, or 110 root 2. So our graph will go up to this because it's sin, and come down through here, and then goes back up to here again. I should have had a minus actually down below the line down there, minus 110 root 2. Right, so third part. So use V of t to find voltage when t is 6.67 seconds. Alright, so this is very simple. This is just a substituting into the formula that was given above. So it said that V of t is 110 root 2 and then sin of 120 pi t. So all we're going to do is we're just going to put the 6.67 in there instead of t. And we'll see what we get. So V of 6.67 is equal to 110 root 2 sine 120 times pi times 6.67. So all that in like that. You use your calculator, then you can put all that in, and you should get 147.95, and that's V. Okay. Right, so next part anyway. So find one value of t where the voltage is 110 volts. So we're going to let 110 be equal to at this time, and we're going to try and solve for t. So you can bring over the root 2, you can bring over the root 2 and the 110 then. So if you divide by 110 root 2, the 110 will cancel out, so we just get 1 over root 2 is equal to sin of 120 pi t. So we're a little bit closer to getting what t is. Now what you can do then straight away is you can do sin inverse of 1 over root 2, so you'll get something there then, is equal to 120 pi t. So bring over the sin next and just do sin of 1 over root 2 and in radians then, so that'll be pi over 4. So pi over 4 equals 120 pi t. There's a pi on both sides there, so those will cancel out, so we get 1 over 4. So when you bring across the 120 and you divide it, you're going to get 1 over 4 times 120, so that's going to be 480 is equal to t. So t is equal to 1 over 480, and then that's in seconds, I think. Yeah, so 1 over 480 seconds. Right, so the last part then, find the rate of change. So wherever you see rate of change, you know that it's going to be, you're just going to be differentiating it. So V of t equals 110 root 2 sin of 120 pi t. So V dash of t will be equal to, so the differential of sin is just cos, it's positive cos, so 110 root 2 cos of 120 pi t, and then because there's a function within a function here. You have to use the chain rule. So you're going to multiply that by the differential of what's inside. So the differential of what's in here, so if you just drop the power of t down by 1, it means that t is gone and you're just left with 120 pi. So 120 pi is basically a constant that's left. So you have to multiply all of that by 120 pi then. So that's the same thing as 110 root 2 times by 120 pi cos of 120 pi t. Okay, and if you look back at the question here, it's when, so that's the differential, it's when t is 2. So you just have to put in a 2 then instead. So v dash of 2 is, and you could go ahead and I think my brackets might be slightly wrong there. It should work out though. Yeah, so that's been multiplied, or kind of been multiplied separately. So put in, so v dash of 2 is equal to 110 root 2 times by 120 pi times by cos of 120 pi times by 2. And that's inside the cos there. So it looks complicated. If you use calculator, we should get 58646 in the end. So that's the final answer then. And yeah, it's to the nearest unit as well, so I've rounded off to the nearest unit. So that's it. That's everything for that question.